Hello student, welcome to the lecture on utility analysis of consumer demand, and after this lecture we will be able to learn the following objectives. Describe the meaning of utility, explain the law of diminishing marginal utility, DMU, give details of the law of equi-marginal utility, talk about the indifference curves. Managerial Economics Introduction. Analysis of the determination of prices of goods and services in the market is an indispensable part of the subject matter of economic theory. When an economy is guided by market mechanism, prices are determined by interaction between demand and supply forces. That is, they are the result of an interaction between decisions taken by buyers and sellers. This is so at all levels of prices, right from the price of an individual good to where all prices are considered simultaneously.
So let's talk about demand. Even though it's good to want things, in economic terms, that's not enough to be able to say that you actually demand something. Formally speaking, demand is defined as being willing, ready, and able to purchase a particular item. So if you really want it but you can't afford it, you don't really demand it. If you want to buy it tomorrow, you still don't demand. Ready, willing, and able. The thing that we don't distinguish is how you're able to pay for something. We don't know whether you have cash up front, whether you're paying for it on your credit card, whatever it may be. We just say that you have the funds in some way to make this transaction happen. We can define demand as either individual demand, how much one person is ready to purchase and is able to purchase of an item. Or we can talk about market demand, the sum of the demand for all of the individuals in a given market. You'll notice that there's an important time element to the concept of demand. The number of ice cream cones, for example, that I demand would depend on whether I'm talking about ice cream cones in a given day, probably less than one, or in a given week, maybe one or two. In a given year, you would keep getting different numbers depending on what time units you put on demand. Now, economists are often sloppy and we don't explicitly put that into the axis of our graph, but it's important to remember that it is always there. This time element also makes it more logical to say things like, I'm demanding 2.5 ice cream cones. To say, for example, I'm demanding 2.5 ice cream cones per week would really just mean that I'm demanding 5 ice cream cones every 2 weeks. The general rule we have about demand, which is referred to as the law of demand, is that all else being equal, individuals demand more of a given item as it gets cheaper. So for example, I'm going to demand more ice cream if the ice cream costs $3 per cone than I would if the ice cream cost $5 per cone. The important thing to remember here is that when we're thinking about the price to a consumer, we're taking into account all of the different components of price the consumer has to pay, including things like taxes, surcharges, required maintenance costs, etc. In a behavioral sense, consumers might not treat all of these different aspects of price the same, but for the basic model, we're at least going to start with the assumption that the consumer internalizes all of those different components of price. When we talk about a demand curve, what we're really referring to is a graph of price versus quantity demanded. You'll notice here that I labeled both a lowercase q and an uppercase q. The distinction that we make in economics a lot of the time is that we use the lowercase q to refer to individual demand, and we use the uppercase q to refer to market demand. The same concepts are going to hold when we talk about individual supply versus market supply. So let's think about a demand curve represented by the equation quantity demanded is equal to 40 minus 5p. The first thing we want to do is say, well, how do we graph this on our axes here? You'll notice that the way that we wrote this demand curve is a little bit different from what you may have seen in your math classes, because we have the variable on the x-axis as a function of the variable on the y-axis. This is just a convention in economics, and it gets very frustrating sometimes, but it is what it is and you can't really fight the trend at this point. So we're just going to think about, well, how can we go about plotting this even though it is in somewhat of a strange form? For a demand curve, the easiest thing to do is just think about what the different intercepts are. So you'll notice that the point on the p-axis here is the point where quantity is equal to 0. So we can go over to our equation and think about, well, if quantity is 0, what is the corresponding price? Well, if quantity is 0, then we just have 40 minus 5p equals 0. Or 5p equals 40, p equals 8. So when quantity is equal to 0, p is equal to 8. And we can put a point, maybe write something like this. Now let's think about the other side of this. The point over here on the q-axis of our demand curve is the point where price is equal to 0. So let's think about where that has to be. Well, if price is equal to 0, quantity demanded is just equal to 40 minus 0, or 40. Notice I'm not really drawing to scale, it's not usually very important. We can see from the form of our equation that this is just going to represent a line on our price and quantity axes. So we can just connect these 2 points. Notice here you get a downward sloping line, which isn't surprising given the law of demand that we talked about earlier. As the price of an item goes up, consumers are demanding less of it, or vice versa, as the price of an item goes down, consumers are demanding more. Notice here that we're holding everything else that could possibly impact demand. We'll come back and talk about this in a little while, things like income, tastes, expectations. We're holding all of those things constant and just thinking about how price affects quantity demanded. Let's think about what the slope of this demand curve is. We say that slope is represented by the change of whatever is on the y-axis divided by the change in whatever is on the x-axis. So in this case, we could say that the slope is equal to the change in p divided by the change in q. Or, say, 8 minus 0 divided by 0 minus 40, which is negative 1/5. You'll notice that when we have the law of demand being satisfied, we get a demand curve that has a negative slope, which corresponds to the demand curve sloping downwards like we see here. In theory, we could have a demand curve that would slope upwards, and we do have names for those type of things, but in practice those examples are very hard to find, so we can say that in the vast majority of cases, demand curves in fact do go in this direction. One other thing that's helpful to note is that when we talk about moving from one point to another point on the same demand curve, we refer to this as a change in quantity demanded. In other words, when we have a change in price that causes us to move from one point to another, we say that this is a change in quantity demanded. We'll see how this differs from a change in demand, which we're going to talk about in the next lecture. Let's say you're super stubborn and say, I need my demand curve to look like it does in my math classes because otherwise I really don't understand what's going on, it's all too confusing. One thing you can do is you can rewrite the demand curve as we see here, and we can just solve for price so that we in fact do have the variable on the y-axis in terms of the variable on the x-axis. In this case, we would just go through and put p on the left-hand side and say 5p is equal to 40 minus quantity demanded. We would then divide through by 5 to get that price is equal to 8 minus 1/5 times the quantity demanded. This is referred to as the inverse demand curve, and it really answers the question, for any given quantity, what is the price that we can charge such that we have that many customers lining up at the door? whereas the regular demand curve says for any given price how many units of that item are demanded. We're not really trying to imply a causal relationship in one way or the other, we're rather just trying to say that price and quantity are correlated in this way. Once you have the demand curve like you see it in your math class, it's pretty straightforward how it relates to the graph that we see here. We have our 8 as our y-intercept, and then we have our negative 1/5 as our slope that goes right here. That said, it's usually easier to become familiar with how to graph the demand curve directly rather than how to move it around and solve for p every time you have to graph a demand curve. Next time we're going to talk about the other determinants of demand, such as income, prices of related goods, tastes, and expectations, and then think about how we can change this demand curve based on changes in these non-price determinants of demand.
Meaning of utility.
Utility theory. This little tutorial goes through and reviews some of the key ideas of utility, as well as showing you how to calculate the marginal utility. Utility is a want or pleasure satisfying characteristic of a good or service. Utility is measured in units of measurement called utils. Utility analysis is the investigation of how consumers reach decisions to achieve utility maximizations. Remember that utility is measured ordinally.
Utility of a good is its expected capacity to satisfy a human want. To a consumer, the utility of a good is the satisfaction which he expects from its consumption. It is the extent to which it is expected to satisfy his wants. It is obvious that utility of a good to a consumer can differ from the satisfaction which he actually derives from its consumption. The fact that utility of a good is the satisfaction which the consumer expects from its consumption implies that it is a subjective thing. Utility versus realized satisfaction. A consumer demands a good on the basis of its utility, that is, expected satisfaction, and not on the basis of actual satisfaction derived from it. Measurement of utility. The need for measuring utility arises so that it can be used in the analysis of demand behavior of individual consumers and therefore of the market as a whole. The basis of the reasoning is that a consumer compares utility of a good with the price he has to pay for it. Concepts of total, average, and marginal utility. Total utility. Total utility is the total amount of utility one derives from consuming goods or services. Total utility decreases or diminishes over time. Marginal utility. Marginal utility is the amount of additional utility the person receives from the consumption of additional unit of a good or service. Marginal utility is equal to the change in total utility divided by change in number of units of consumption.
As consumers, we make choices every day about what and how much to buy and use. In order to model how consumers make these decisions, economists traditionally assume that people make choices that maximize their levels of happiness. Economists even have their own word for happiness. Utility is the amount of happiness gained from consuming a good or service. This concept of economic utility has some specific properties that are important to keep in mind. If consuming a good confers positive utility on a consumer, consuming that good makes the consumer happier. In other words, positive utility numbers are, well, positive. Conversely, negative utility numbers associated with consuming a good indicate that consuming that good makes the consumer less happy. The greater the utility number, the more happiness the consumer receives from consuming an item. This is consistent with the last point, since large negative numbers are smaller, or less than, small negative numbers. and being a lot unhappy is worse than being a little unhappy. Utility numbers can be compared, but it doesn't necessarily make sense to perform calculations with them. In other words, while it is the case that a utility of 6 is better than a utility of 3, it's not necessarily the case that a utility of 6 is twice as good as a utility of 3. Similarly, it's not necessarily the case that a utility of 2 and a utility of 3 would add to a utility of 5. Economists use the concept of utility to model consumers' preferences, since it stands to reason that consumers prefer items that give them higher levels of utility. The consumer's decision regarding what to consume, therefore, boils down to answering the question, what affordable combination of goods and services gives me the most happiness? In the utility maximization model, the affordable part of the question is represented by a budget constraint, and the happiness part is represented by what are known as indifference curves. We'll examine each of these in turn and then put them together to arrive at the consumer's optimal consumption.
Law of Diminishing Marginal Utility, DMU. The law of diminishing marginal utility states that as the stock of a commodity increases with the consumer, its marginal utility to the consumer decreases. It can eventually fall to zero and become negative. The law describes a familiar psychological tendency of the human beings. Uses of the law of DMU. The concept of marginal utility of a good and the manner in which it changes in relation to a change in its stock with a typical consumer plays a central role in demand analysis. It is directly linked with the price which the consumer is ready to pay for different quantities of the good under consideration. The relationship between diminishing marginal utility of a good and its price helps us in explaining the determination of its price in the market. The law of DMU can be extended to the case where a consumer is faced with the decision to divide his total expenditure over a number of goods. Given the law of DMU, economic rationality of the consumer leads us to the conclusion to define and measure consumer's surplus, which is defined as the excess of the maximum price which is the consumer ready to pay for the good over the price which he actually pays for it. The law of DMU is highly useful to the authorities also in working out their social welfare programs. They can take steps by which goods and services are allocated between members of the society in such a way that marginal utility of each good or service tends to be the same for every individual. Law of Equip Marginal Utility. The law of diminishing marginal utility plays a crucial role in explaining the demand behavior of a typical consumer and determination of his equilibrium when he is facing the following circumstances. It is clear that the consumer's equilibrium will change if there is a change in his total expenditure, marginal utility schedule of any good, or price of any good. Limitations of the law. In reality, the law of Equip Marginal Utility suffers from several limitations which come in the way of its implementation by the consumer. The goods on which the consumer spends his money are perfectly divisible. The law also suffers from the unrealistic nature of its other assumptions. One such assumption is that the consumer has complete knowledge of the prices and availability of all consumer goods. The law assumes independence of utility schedules of goods. It means that utility derived from one good is not affected by the quantity purchased of other goods. Indifference curves. Utility approach suffers from several drawbacks. For this reason, a consumer's demand curve derived with the help of utility approach also suffers from similar drawbacks. In particular, mention may be made of the assumptions of constant marginal utility of money and cardinal measurement of utility, as also its inability to handle the case of inferior goods and income effect. The technique of indifference curves tries to avoid these drawbacks and provide a technically superior analysis of demand. Budget price line (BPL). In indifference curves approach to demand analysis, budget price line (BPL) plays an integral role in the determination of consumers' equilibrium. It is a straight line joining 2 points on y-axis and x-axis and has a negative slope. Its starting point on y-axis represents the amount of y that can be bought with given label and price of y, Py. Its end point on x-axis represents the maximum amount of x which consumer can buy with given income and price of x, Px. Summary. A demand function of an individual buyer is an algebraic form of expressing his demand behavior. The position of equilibrium is attained by the consumer where his budget price line is tangent to one of his indifferent curves. Law of demand describes the changes in the market demand for a good in relation to its alternative prices. The law makes a questionable assumption that the consumer is able to accurately determine the marginal utility schedules of all the goods. A consumer demands a good on the basis of its utility, that is, expected satisfaction, and not on the basis of actual satisfaction derived from it.